Hi everyone, this video is going to cover how to write electron configuration. So we're going to be using the periodic table to interpret graphical representations of electron arrangement, specifically in this one through electron configuration. We're not going to talk about what electron configuration means yet. We're just going to go over how to write the electron configuration. After you're able to write the electron configuration, then it makes a lot more sense how this all works, but it's really great to have a foundation of just how to write it first. In order to go through how to write electron configuration, we're going to start by looking at energy levels. Then we're going to talk about blocks of the periodic table. And we're going to spend a bulk of our time with number 3 and 4 going over some examples and special rules. At the very end, we'll do some practice questions to just check in and make sure you understand what you are doing. So grab a periodic table and maybe a piece of paper off to the side as well. And let's get started talking about energy levels. So you know, based on Bohr's model, that an atom has different energy levels where the electrons exist. So like this atom, we can see 3 electrons there. We've got 2 electrons on the first energy level, and we've got 1 electron here on the second energy level. So these energy levels, we know that an electron out here on the second one has more energy than on the first. And we know that that also is a bigger orbital, and we can hold more electrons in it. So energy levels in terms of electron configuration are very similar, but we are going to be getting the energy level number from the period number on the periodic table. So grab the periodic table you're using, and you are going to label 1 through 7 down the side because we have 7 rows on the periodic table, and those are going to be the energy levels. So you can label these are energy levels. Just like kind of like the rings on the Bohr model, we've got energy levels here. Okay, check. We've talked about energy levels. The next thing that we're going to do is we're going to talk about the blocks of the periodic table. There are 4 blocks of the periodic table. We've got S, P, D, and F. So what you need to do is label your periodic table so you also have 4 blocks. The S block, you'll notice we moved helium over here. So helium normally is over here. For electron configuration, it's really handy if it lives over here. So scribble it out on that side, redraw it over here. And you're going to label groups 1 and 2 as the S block. You will learn later what these blocks mean. Right now, just know that this is called the S block. The P block is over here, groups 13 through 18, minus helium, of course. So this is the P block. The D block, those are the transition metals. So label that middle section as the D block. And then on a traditional periodic table, the F block would be underneath and its own separate little island. But this periodic table is the F block inserted where it's supposed to go, so it's extended and it's just easier for electron configuration. But the lanthanides and actinides, those are going to be the F block. So once you have your periodic table all labeled, you are set and ready to start looking at some different examples of electron configuration. So we're going to start really simple, and then we're going to build up as we go. Make sure you follow along and you're watching for patterns. Patterns are the name of the game when it comes to electron configuration. So we're going to start really simple, and we're going to start with hydrogen. Whenever you do an electron configuration, you go across the rows on the periodic table in order until you get to that element. We're starting with hydrogen, so we're starting really simple. We don't have to go far, just here. The first thing you do is write down the energy level. So hydrogen right here, we're in the first energy level. Then you write down the block. So we've got the S block. And then you're going to count over how many elements you went, and we just went over 1 element. So this is the electron configuration for hydrogen. It's just 1s1. Let's try a little bit more difficult of an example. We're not going to go much further, but let's go to helium this time. For helium, we go here. So we're just going across the row until we get to helium. We're in the first, we're in the first row. First energy level. Now we write down the block, it's S, and we go over 1, 2 elements, we've got 2. And that's the electron configuration for helium. Let's start adding to this a little bit. So after this, after helium, we finished that first row, and now we're about to start the second row. Anytime you start a new row or you start a new period, you have to start a new electron configuration, what I'm going to call a segment. So this would be a segment of electron configuration. So anytime you start a new row, you have to start a new little segment. So for example, let's write out the electron configuration for beryllium. In order to get beryllium, we have to go across the rows until we get there. Well, after this first row, there's nothing else, so we start the second row. Let's go through all of those little segments. This first part, we're in the first row, S block, and we went over 1 2 element tiles. Now we start a new row, so we're going to start a new segment. We're in the second row, we're still in the S block, and we went over 2 elements. And that is our electron configuration for beryllium. We're just going to slowly add to this until we're getting the hang of it. And we're going to try the electron configuration for fluorine, F. In order to get there, we're going to go across the first row. That ends the first row. We'll go to the second row, and then we're going to have to go to a new block. So just like whenever you start a new period, you start a new electron configuration segment. The same is true for a new block. So whenever you start a new block, you will start another new electron configuration segment. So let's see what that means. So we start up here. We're in the first row, S block, and we went over 2 element tiles. So 1s2. That ends the first row. Let's start the second row. Now we're in the second row, the S block, and we went over 1 2 element tiles, so 2. There's nothing here in the center, but bam, we had a new block, the P block, new segment. So we write down 2P, we go 1 2 3 4 5, 2P 5. And that's our configuration for fluorine. Why don't you try one on your own, and then we'll go over it. How about you try to write out the electron configuration for argon, AR. Try to write the electron configuration for argon on your piece of paper. Okay, let's go over your answer for argon. So if we map out where we're going, we go across the first row. That ends the first row. The second row, nothing here in the center. We'll go across the P block here. We'll start a new row, keep going, but there's nothing here. And then finally we get to argon here on the end. So now let's write all of that out. So this first part, we write 1. We're in the S block, and then we go 1 2 elements. That finishes that row. Then we go to the second row. We're in the S block, and we count over 1 2 elements. We start a new block. We have a new little segment, second row, P block. And we go 1 2 3 4 5 6, 6. That ends the second row, sorry. And now we're going to go to the third row. Back in the S block, go over 2 element tiles, 2. We keep going across the third row. We go to the P block, so a new segment, P block, and we go 1 2 3 4 5 6 to get to argon. So argon's configuration is 1s2, 2s2, 2p6, 3s2, 3p6. You're noticing that these are getting a little bit long, and we're still pretty early in the periodic table, which means by the time we get down in this region, we're going to have some long configurations. All right, let's add on some new rules. So now that you guys are kind of familiar with some of the examples, let's try some special rules. And there are special rules whenever you get to the D block and to the F block. So when you get to the D block, which would be right here, you would start the D block. Something weird happens. Even though this is part of the fourth row, you subtract 1 whenever you go through the D block. So after 4s2 right here, nothing is here in the center. When you get to the D block, instead of writing 4D, you actually write 3D. So this is really 3D. But then when you go back to the P block, now it's normal. And so this would still be 4P right there. So that's what's special when you get to the D block. Let's do an example of that together so you can see how it works. We're going to write out the electron configuration for barium. So this is going to be a long configuration. Why don't you pause the video and take a moment and try to do the first part. So maybe through like calcium, and then we'll start on the rest of it together. So pause the video and try the first part on your own. Okay, for barium, you did the first part on your own. So we start always at hydrogen and go across. We've got 1 S, we went over 2. That ends our first row. Now for the second row, we'll write 2. We're in the S block, and we'll go 1, 2 elements. Nothing here, and then bam, we've got the P block. So we're in the second row, P block, and we go 1, 2, 3, 4, 5, 6. That ends the second row. We go to the third row, S block, 1, 2 elements. Nothing here in the center, and P block. That is the third row, P block. We count 1, 2, 3, 4, 5, 6. That ends the third row. So now in the fourth row, S block, 2 elements. Nothing, and then the D block. So when you get to this D block, we're going to subtract 1. Instead of 4D, it's actually 3D. We subtract 1. We're going to count across like normal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're in the P block, so we'll start a new segment again. We're in the fourth row, P block, and if we count across, we get 6. We're almost to barium, we're almost there. We keep going, we're in the fifth row, S block, 2 elements. Nothing here. Get to the D block again, so we'll subtract 1. Even though we're in the fifth row, this becomes 4D, and if we count all the way across, we'll get 10. Go back to the P block. We're in the fifth row, the P block, and if we count across, we'll see 6 elements. And then the last part of barium is the sixth row, the S block, and we go over 2 elements. So that is a long configuration, but that is the electron configuration for barium. There's only one special rule left. So when you get to the D block, we said you subtract 1. When you get to the F block, you subtract 2. So just like how this instead of 4D was actually 3D, well, this is part of the 6th row, you're going to subtract 2. So instead of 6F, it's actually just 4F. So this is 4F. And if you want to label that on your periodic table, that's great. So let's read across the 6th row because that could just be a little confusing. So across the 6th row, we've got 6S. Then we said we have 4F. And then we get to the D block, we subtract 1 from our energy level. So now this is 5D. And then we get to the P block, we're back to normal. So this would be 6P. I know that's a little hard to see, but that is 6P. So that's pretty crazy. When we read across there, be very careful. You've got 6S, 4F, 5D, and then 6P. So let's try an example where we have something that goes through the F block. So why don't we try thorium? TH, thorium. Go ahead and pause the video and try to do thorium on your own, and then let's go over it. So take a moment and try to write out the electron configuration for thorium. Okay, so we're going to pick up the configuration here together. So this is all the way through 5p6, which would take us through here, through xenon. And let's finish up the rest of this together. So after 5p6, we're going to go down to 6s2. Then we're going to 4f. And if we count all the way across, you'll see 14 there. Now we're going back to the D block. So we've got 5D, and all the way across is 10. Then we go to the P block, and we've got 6P6. Almost done with this one. We've got 7s2, and then our very last part. So even though we're in the 7th row right here, we're going to subtract 2. So this is 5F and 2. And that would be our electron configuration for thorium. So those are our special rules. When you get to the D block, subtract 1. F block, subtract 2. Special rules, check. Last thing to do is let's do a couple practice questions. So let's pick a couple elements and you guys try to write the electron configuration for them, and then we'll go over the answers. Let's pick out 3 of these. For the first one, try to write the electron configuration of sodium. That's Na. For the second one, write out the electron configuration for bromine, Br. And the last one, let's have you write out the electron configuration for tennessine, Ts. So you've got sodium, bromine, and tennessine. Pause the video, work on these questions, and then play the video when you're ready to check your answers. Okay, for the first one, for sodium, the electron configuration is 1s2, 2s2, 2p6, and then 3s1. So that's your answer for sodium. Next, the answer for bromine. Bromine is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, because we subtract 1, 10, and then 4p5 to get to bromine. The last one is quite the challenge, and it is tennessine. And the answer for tennessine should look like this. You've got 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, subtract 2. So 4F14, subtract 1, so you have 5D10, back to normal, 6P6, 7S2, subtract 2, 5F14, subtract 1, 6D10, and lastly is 7P5. If you can do the configuration for tennessine, you can do the configuration for anything. And the last thing for a practice problem before we wrap all this up, let's say you had this configuration, 1s2, 2s2, 2p6, 3s2, 3p2. Could you figure out what element that is? Take a second, look at your periodic table, and try to figure out what element that is. Hopefully you found this last little part, 3p2. So this element would be silicon, Si. All right, and that was our last piece of electron configuration to do some practice questions. So you can now, congratulations, join the elite club of those able to write out electron configuration.